Bismillahirrahmanirrahim. In this lecture, I am going to explain the different types of the thermodynamics properties, and these are called the intensive properties and the extensive property. Intensive property is simply the mass independent. So starting with the I and independent is also starting with the I. So you can simply understand intensive mean independent of mass. Extensive mean dependent on mass. So the definition is given over here. Intensive properties do not depend on the amount of matter in a sample, that means independent of the mass. So some example are given over here. Let's suppose it is the boiling point. If you take 100 ml of water or 1000 ml of water, 2 liter or 4 liter or 1 gram of water, then the boiling point of water will remain the same. That means it is the 100 degrees centigrade. So this is not going to change with the matter. If you increase the matter, boiling point is not going to increase or the decrease. So that's why this is called the intensive property. It is not going to depend on the amount of the matter. The second example is the temperature, and this is also the intensive property, and this is not going to depend on the matter. If let's suppose if you are sitting in a room, if the temperature is 25 degrees centigrade, and if you have half of the portion of the room, the temperature will also be the same. And or if you in generally, if you uh, want to check the temperature, let's suppose of your body, so it would, let's suppose if it would be a 98 Fahrenheit, so the temperature of whole of the body is going to be 98 Fahrenheit. That means this is not going to depend on the matter, so temperature is also the intensive property. Other one is the, let's suppose this is the luster shining of any material. If it is, let's suppose 1 cubic meter of the material or 100 cubic meter of the material, this is the shining will be the same. This is not going to depend. That's why the luster is also a intensive property. Another important terms you are going to use in your daily experiments, this is the concentration. This is also the intensive property. It is not going to depend on the mass or the matter. Why? Because if you prepare, let's suppose 1000 ml of zero point 0.1 molar concentration of sodium chloride. So even if you take 100 ml out of this, 1 ml out of this, 10 ml out of this, each one 10 or 100 ml is having the same concentration, which is the zero point 0.1 or the 1 molar concentration. So the concentration is not going to change with the volume or the matter, unless you would add a water inside in addition, or the matter inside in addition, then of course the concentration is going to change. So actually we are talking about if you have prepared 1 molar concentration of the sodium chloride, whatever it is the volume, if you take any of the volume out of this flask, the concentration of sodium chloride is not going to change. It will remain the same as it is the 1 molar concentration. So it is the mass independent, or you can call it the intensive property. So moving on the extensive properties. Extensive properties depend on how much matter a sample contain. So that means it is going to depend on the mass of the matter. Let's suppose this is the weight. Weight, this is a simple term. Weight is the extensive property. If it is, if you increase the mass or the matter, the weight is going to increase. That means if it is 1 gram, if you increase the matter, that means if you adding the mass over here, it is going to increase to from 1 gram to the 2 gram. So that means the weight is going to be depend on the matter of the mass. That's why this is the extensive properties. In a similar way, this is the length. Length is also matter dependent. So let's suppose this is the 1 inch of length, and if you increase the matter, so that means the length is going to increase, which is showing that this is the extensive property. Again, the volume. This is a small volume. This is a large volume. This is small volume. That means having a small weight or the matter, and by increasing the matter the volume is going to increase. That means this is the extensive property. Again, entropy is just a randomness. If by increasing the matter, the entropy is going to increase, and this is the extensive property. So it is very important to understand to differentiate between the intensive and the extensive properties. Some of the intensive properties are mentioned over here. You can focus on and concentrate on them and to decide why these are the intensive property. That means the mass independent properties. And some more intensive and extensive properties are mentioned over here, which are independent of mass and dependent of mass. That's temperature, pressure, density, boiling point, color, luster, density, conductivity. All these are the intensive properties. But extensive property like volume, internal energy, kinetic energy, mass, weight, length, these are the extensive property. So, as a student or the learner, know what should be a basic criteria to differentiate between the intensive or the extensive properties. Let's suppose if this is the volume, this is the extensive property, but the specific volume is the intensive property. So you might be thinking about, so how can we differentiate either this is the volume or the specific volume, or whether which of the property or the type is the intensive and the extensive property. So actually now I'm going to explain. This is the very simple understanding in physical chemistry. If you have a look on the units of all these terms, you can easily understand the extensive and the intensive properties. So again, this is the mass dependent, this is the mass independent. So increasing the mass, of course, will increase the, this is again the mass will of course increase the mass. Increasing the matter, increasing the mass. Increasing the matter will going to increase the charge. Increasing the mass or the matter will going to increase the volume. And similarly, this is going to be carried out with this. And first have a look on the other side. So this is the specific volume, this is the volume having the unit meter cube, which is the extensive property, and the specific volume is having the unit meter cube per kilogram. So see the difference first with the units. What is the volume and the specific volume? So this is the in general volume. If you increase the matter or the mass, the volume is going to increase. But here you have specified a volume with the unit, which is called the per kilogram. So when you are going to measure the volume of any uh, matter per kilogram, it will remain the constant. That we know it is not going to depend on the matter. Let's suppose if you have 1 kilogram of the water, and you can measure its volume, So 1 kilogram of the water will remain the same if you, let's suppose, if you add more water inside that volume. Again, you have to measure the volume of 1 kilogram of the water, and it will having the constant unit or constant figure, which is the specific volume. So that's why this is the intensive property, this is the extensive property. Let me first explain another unit. This is the energy, this is the specific energy, and if you increase the mass or the matter, of course the energy is going to increase. It depends on the matter. But what would be the specific energy? This is the energy per kilogram of the material. So when you have taken the specify a mass, it is the energy of 1 kilogram of the matter, then you must have a constant value, and this is called the specific energy. That means you have specified the energy with the per kilogram of the matter. That's why this is the specific energy, and this is the intensive property, this is the extensive property. So now, very briefly, I'm going to differentiate between the extensive and the intensive property. So any units, these are, look at the units, these are the sum of the units are in the mass or the other units in second. If you find the units with which is the specified with the matter, that means meter cube per kilogram, kilojoule per kilogram, kilojoule per kilogram, meter per second, kilojoule per Kelvin per kilogram. This is important over here, per kilogram. That means per kilogram per second. So that means all these are the intensive property which are the independent of the mass, but here these are the extensive property where there is no per mass is given over here. These are the extensive property. Some of the contrary to my definition over here, some are the units which are not having per kilogram over here. Let's suppose it is the pressure is having a unit of atmosphere or the kilopascal, but it is the hidden per is there. That means the pressure is the force per unit area. So in a unit area, whatever it is the force that will remain the constant. So that's why the pressure is having the uh, intensive property, because pressure is the force per unit area, or you can say atmosphere per meter cube or the centimeter square. Sorry, it is the area. So meter atmosphere per centimeter square or the meter square, that is called the pressure. So there are per meter square is there. That's why the pressure is also the intensive property. So you have to look into the detail the definition of each of the terms. So in the similar way, this is the temperature is having the unit of Kelvin, centigrade, or the Fahrenheit. This is also intensive property, because the temperature of the system is thermal equilibrium and is the same as the temperature of any part of it. That means if it is the temperature of, if you can take a water of 100 ml and you can measure the temperature, it is 25 degrees Celsius. And if you measure individually 10 ml, 500 ml, or the 100 ml, then this will also give the same temperature. That means this is not going to depend on the mass. That's why the temperature is also the intensive property. So these are for your exercise. You can further, based on what I have defined previously, the differentiation between these thermodynamic parameters, sorry, the properties, and by looking at the units, you can differentiate whether this is the intensive property or the extensive property. So based on this, you can differentiate. Here, I am just going to define one of the terms over here. Let's suppose these are the terms joule per Kelvin, joule per Kelvin, joule per Kelvin, heat capacity. But you might be confused over here because the joule per Kelvin is here, so it must be a intensive property. But here it is the specific heat capacity or the specific energies are the intensive property. So by definition, the heat capacity over here is the amount of heat that move into or out of the object to change its temperature by 1 degree Celsius. So this is per Kelvin or the per Celsius is just the it is going to define the heat capacity. Again, it is the amount of heat that move into or out of the object to change its temperature by 1 degree Celsius. That is the heat capacity, and it is the molar sorry extensive property. But what would be the specific heat? It is the energy needed to raise the temperature of 1 mole or 1 kilogram of a substance by 1 degree Kelvin or the Celsius. That is called the molar heat or the specific heat capacity. So molar is just if you replace the kilogram with the molar, that will be the molar heat capacity. Otherwise, with the kilogram, you can say it is the specific heat capacity. And molar heat capacity is also a specific heat capacity. You are because you are going to specify with the moles, and here you are going to specify it with the kilograms. So here this is important. That's why this is the intensive property and this is the extensive property. So this is all about the properties of the thermodynamic properties.